Now we're going to talk about transformations on functions. Now this is something we're going to spread out over a few videos and topics in class. But let's start with just the four basic transformations. Now we're going to save why these transformations do what they do to a later video. We're just going to go through what they are, how to perform them, and then we'll actually perform to some graphs. And once we get into the habit of graphing them, then we can really explore the graphs and understand why these transformations do what they do to the coordinates. So the idea is I could sketch something by just substituting in numbers, or I could perform transformations to it. So we start with some sort of key function, a parent function like we talked about in the previous video, or any function. So this could be anything. And what we do is we apply to end up with this one here. Now notice it's still got the F, but it's got new stuff. It's got A, K, D, and C. A, K, D, and C have been added to it. So each of these performs a different transformation. Each of these numbers has an effect on the graph. So I've already got this filled out for us. So let's just go through it really quickly. Let's talk about what A does first. Now, the easiest ones to spot are the A and the C because they're outside the function. The A is out front, the C is usually put behind. They're the easiest ones to spot, and they're the most straightforward. So the A here, what we do is we multiply all our y coordinates by A. So we take those coordinates from our parent function or our base function that we're starting with, we multiply the y coordinates by whatever that is. Now, it has two effects. If it's a negative, what it does is it reflects it. So here's my original function here. So if it's a negative number and I multiply, it flips down like this. So all the y coordinates change from positive to negative or negative to positive. So it flips it. The other effect it can have is cause a vertical stretch. Or a compression. We can just call them stretches for now to keep it simple. But a vertical stretch, by multiplying the y coordinates by a number, it makes them higher or lower. So it could stretch it like this, or if it makes them lower, it could shrink them down to a compression like this. All right, so that's what y does. And we're going to use short forms in our next notes. So instead of writing vertical reflection every time, I'm going to write VR. Instead of writing vertical stretch each time, I'm going to write VS. It'll help move things along a little quicker. All right, now the next one we want to talk about is what K does. So K has a similar effect. It's a little harder to spot because it's inside our function. Notice it's inside the brackets here. So whatever our function is, whether it's square root or absolute value or squaring or cubing, it's going to be inside of that function. So what we do, and explaining this, we're going to explain a little now and a little in the next videos. That's the K here. Now, we take that and we multiply the X coordinates, but we don't multiply them by K. We actually multiply them by 1 over K. Now, that's the same thing, though, as saying divide them. So divide by K is another way of thinking about it. So instead of multiplying by K, we're dividing by K. So I could write as X as 1 over K, or 1 over K times X, or I could just write X divided by K. It means the same thing, right? Multiplying by 1 over K, same as dividing. So we're dividing by whatever K is. Now, it has a similar effect. If this is my original function here, when I multiply it by a negative, it flips it, right? The x coordinates that were positive now become negative. It causes a horizontal reflection. We use HR for short for that. And it can also stretch it. So if this is my original, it can pull it this way, make it longer, or it could compress it, right, by pushing it in this way. We can call those all stretches to keep it simple for now, but if you want to be technical and sound smart and know what you're talking about, technically, if you were shrinking it, it's a compression, not a stretch. All right, let's move on to the next one. Now, the last two are the easiest ones to perform. So D and C. Now, we got to be careful because, again, notice when we were working with A, it was exactly what we saw, but with K, we actually divide by that number. We do the reciprocal. We multiply by 1 over K. Well, same with the value of D here. Instead of that minus there, we actually take the opposite sign because it's X minus whatever the value of D is. So if you have something like X minus 2, that means D would be equal to 2. If you have something like X plus 3, D would actually be equal to negative 3 because that's the same thing as saying X minus negative 3. So D, in that case, would be equal to negative 3. So long story short, you take the opposite sign versus what you see. Now the C is the easiest to spot because he's right at the back, and you take him at face value. If it's plus something, that you leave it the same. If it's minus, you leave it the same. So let's scroll down and look at what those do. Now they're pretty quick. We take what we did before, so we take the 1 over K for X. I should say the 1 over K that we multiplied X by or divided X by K, and we just add D to it. So what that does is it shifts all our coordinates either to the left, or sorry, to the right, or to the left. So if it's a positive number, everything moves to the right. If it's a negative number, everything moves to the left. And we call that a horizontal translation, which is just a fancy way of saying moving left or right. And we'll use HT for short for that. Now, with the y coordinates, we're just going to add whatever c is to what we did before. So we take what we had before, which we multiply them by a, and we finish by adding c. All that does is move our points up or moves all our points down. So if it's positive, they go up, negative, they go down, because we're just adding to the y coordinates. And again, we'll call that a vertical translation, which is a fancy way of saying up or down. Vertical translation, moving, and however many units we move. So now, we got to make sure we always do the stretches and reflections first. So we call these, the fancy word for that is dilations. We can call them stretches to keep it simple. And our translations second, which is the idea of moving left or right, or up